So this is the 32nd session on rigid body kinematics. Okay. In this video, I'll take up some other question which is not strictly of rigid body kinematics. Okay, but it is some interrelated concepts are there. So what we'll do basically, we'll write down the expression for relative acceleration between two moving points which are confined always to move in same plane as seen from some frame F in cylindrical coordinate representation. Okay, this is an important concept for certain class of questions, okay, which are solved by this method very nicely. So I'll write down the first what we are going to discuss in this channel, okay, in this video. That will be of great help. You must understand it fully. If you understand this fully, then it will be of great help to you, okay. And if you have any doubt, you can write it in the comment box. I'll just look into it and then explain it to you. Fine, all right. So what I'll do, we are given 2 points P1 and P2 and some frame F. P1 and P2 always move in the same plane as seen from F, okay. We have to write down the expression for relative acceleration between these 2 points in frame F in cylindrical coordinate representation. Okay, fine. So see, this is some frame F, okay. Some given F is some given reference frame. And P1 and P2 are 2 moving points in this frame, with the only restriction that P1 and P2 always move in the same plane as seen from F, okay. They always move in a common plane as seen from F. At some instant, R is the separation between P1 and P2. So we have taken a coordinate system which is fixed in the frame F. Suppose x rightward, y upward, okay. So ER hat is a unit vector from P1 to P2. And suppose at certain instant, due to motion of these 2 points P1 and P2, this line P1 and P2 rotates in say anti-clockwise sense, like this, omega. Okay, so this is the unit vector along normal to ER hat along the sense of omega. Fine, is it clear what I have said? So P1 and P2 are 2 moving points. Separation between these 2 points is R. ER hat is a unit vector from P1 to P2. I assume that at the instant of interest, line P1 and P2 rotates in anti-clockwise sense with respect to frame F. Omega and anti-clockwise. Omega denotes the angular speed of this line at certain instant. And E theta hat is a unit vector normal to ER hat corresponding to sense of omega. If omega was clockwise, then E theta hat would be in this direction. Since omega is anti-clockwise, so E theta hat is in this direction. Okay. And suppose this line makes an angle of say theta, this line at certain instant with positive x-axis. Okay, x is fixed in the frame F. Then angular speed of this line is d theta by dt. Okay. And angular acceleration of this line is beta barabar d2 theta by dt2. I'll just write it first, this one. And beta is the angular acceleration of this line P1 P2 with respect to frame F. That is just equal to d omega by dt. So that is same as d by dt of d theta by dt. So this becomes how much? d2 theta by dt2. Okay, fine. So ER hat is a unit vector from P1 to P2. E theta hat is a unit vector normal to P1 P2 in the plane of motion corresponding to sense of omega. Fine. And at certain instant, this line P1 P2 makes an angle of theta with positive x-axis. Okay. And R is the vector from P1 to P2. R can be written as R times ER hat. Alright. So vector R will be written as what? R times ER hat. This is how vector R is going to be written. Alright. So see, let us assume that velocity of P1 with respect to frame F is V1F and velocity of P2 with respect to F is V2F. Okay, fine. And also let us assume that the acceleration of P1 with respect to frame F at time t is A1F and acceleration of P2 with respect to frame F at time t is A2F. Alright, fine. So we'll proceed in systematic way. Okay. First, what we do is start from here. Vp2 P1F, that is equal to V2F minus V1F. What is Vp2 P1F? It is the relative velocity of point P2 with respect to point P1 in frame F, okay, which was discussed in great details in the videos on relative velocity. If you go there, you get it there, okay. Now this we know, this is nothing but the derivative of vector R as seen from frame F. This is equal to V2F minus V1F. Okay, so this term is equal to this much. R is R into ER, so substitute it here. Vp2 P1F is equal to d by dt of R ER hat in frame F. Okay, so this I write as from product rule of calculus dr by dt ER hat plus R der by dt in frame F. Now one thing should be noted, as the points P1 and P2 move with respect to F, direction of ER hat in general changes with time. So it's not ER is not a constant vector as seen from frame F. So der by dt in frame F is definitely a non-zero vector in general case. Okay, so this term will be there. Now we must find this first. Now what we do, I express ER and E theta in terms of unit vectors I and j. So see, ER hat makes an angle of theta with positive x-axis. So from theory of vector, ER hat will be written as cos theta I hat plus sin theta j hat. Okay. Now E theta makes an angle, E theta is at right angles to ER. So E theta makes an angle of how much? 90 plus theta with positive x-axis. See, this is theta, this is 90, this is 90 plus theta. Here E theta hat makes an angle of 90 degree plus theta with positive x-axis. So E theta hat is what? That is same as cos of 90 degree plus theta into I hat plus sine of 90 degree plus theta into j hat. So this becomes minus sine theta I hat. This becomes cos theta from trigonometry, cos theta j hat. This is the expression for E theta. Alright. So E theta hat becomes how much? Minus sine theta I plus cos theta j. And ER hat is this much, cos theta I hat plus sine theta j hat. Alright, fine. Now this side of it, okay, fine. So at this instant, we are calculating the relative velocity between these 2 points in frame F in cylindrical coordinate representation. Alright, fine. So now what I do, I derivate this in frame F. der by dt in frame F becomes how much? d by dt of cos theta I hat plus sin theta j hat in frame F. That becomes d by dt of cos theta I hat plus d by dt of sin theta into j hat. Now here di by dt hat becomes 0 in frame F, constant vector. dj hat by dt in frame F also becomes 0 in frame F, constant vector. So derivative becomes 0. And this we write, differentiate using the chain rule of calculus. d by d theta of cos theta into d theta by dt into I hat plus d by d theta into sin theta into d theta by dt into j hat. This becomes minus sin theta. d theta by dt becomes omega. This becomes cos theta. d theta by dt becomes omega into j hat. Omega becomes common. Sin theta I hat plus cos theta j hat. Minus sin theta I hat plus cos theta j hat is E theta hat. So this becomes omega into E theta hat. Okay. So now what I do, you substitute this term in this formula. So from this we get Vp2 P1F is just equal to dr by dt in ER hat plus R omega into E theta hat. So this is the expression for relative velocity between 2 points in cylindrical coordinate representation for the case when the 2 points P1 and P2 are always confined to move in same plane as seen from some given reference frame F. When seen from some given reference frame F, points P1 and P2 are always confined to move in the same plane. Points P1 and P2 are always confined to move in same plane. The relative velocity between these 2 points in frame F at arbitrary instant in cylindrical coordinate representation is written in this way. Alright, fine. Is it alright? So this side of it, okay. So Vp2 P1F in frame F becomes this much. Cylindrical coordinate representation of relative velocity between two moving points in frame F for the case when the 2 points are confined to move in the same plane, as seen from frame F. Okay, fine. Now what you have to do next? Okay, fine. At this point, I would like to say one thing. See, Vp2 P1F is this much. dr by dt into er hat, r omega into e theta hat. Okay. At this point, we consider two different cases. No, I'll just I'll let it remain like this. Okay, fine. All right. Now, what do we do next? That is the question. What to do next? Okay. See, now I proceed ahead. Okay. Now let us calculate this quantity AP2P1F. What does AP2P1F mean? Relative acceleration of point P2 with respect to point P1 in frame F. That is just the derivative of Vp2P1F in frame F. Okay. So this becomes d by dt of, this becomes dr by dt into here, this one I substitute, this I substitute here, r omega into e theta hat in frame F. On this side, differentiate using the usual rules of calculus. So d by dt of dr by dt into er hat in frame F plus d by dt of r omega e theta hat in frame F. On this I differentiate using product rule of calculus. So this becomes er hat into d by dt of dr by dt plus dr by dt into d by dt of er hat in frame F. This also I differentiate using product rule of calculus. So this becomes dr by dt into omega into e theta hat plus r e theta hat d omega by dt plus r omega d e theta hat by dt in frame F. Okay, fine. Now rub this one. Okay. So now, see, all these terms, this term has already been calculated before. This term is also alright. This is also alright. This term d theta by dt in frame F should be evaluated. So first I calculate this, then I substitute in this one. Okay. Now remember what I write for er hat. Er hat I wrote as what? Cos theta I hat plus sin theta j hat. And what about e theta hat? As I calculated just now, minus sin theta I hat plus cos theta j hat. Okay. Now we are interested in what term? D theta by dt in frame F. This is what interested. So this becomes d by dt of minus sin theta I hat plus cos theta j hat in frame F. Now this I write as minus d by dt of sin theta I hat in frame F plus d by dt of cos theta j hat in frame F. Now this I differentiate I hat because constant factor comes outside. D by dt of sin theta J hat is also constant vector as seen from F, into d by dt of cos theta, okay, minus I hat. I differentiate is using the chain rule of calculus. D by d theta of sin theta into d theta by dt plus d by d theta of cos theta into d theta by dt. Now this becomes omega d theta by dt. This also d theta by dt becomes omega. D by d theta of sin theta becomes cos theta minus I hat cos theta omega plus j hat minus sin theta. D by d theta of cos theta is minus sin theta into omega. So minus omega comes outside. I hat cos theta plus j hat sin theta. Now this term is nothing but minus omega into er hat. So this term is minus omega into er hat. Alright, fine. Is it alright? D theta by dt in frame F is nothing but minus omega into er hat. Alright, fine. Now what I do, I rub this. Okay. So I rub every complete thing here. Okay. This I rub it. Okay, fine. So P2 P1F becomes what? This becomes d2r by dt2. This becomes, this term is what? Omega e theta plus dr by dt omega into e theta hat, this one, plus dr by dt omega into e theta hat. This becomes r into, this becomes beta, angular acceleration of the line P1 P2 with respect to frame F at time t, into e theta hat plus r omega. This becomes minus omega e theta as was written here, minus omega into er, sorry, minus omega into er. Alright, so here er, here also er common. So this becomes d2r by dt2 minus omega square r into er hat plus 2 times omega into dr by dt plus r beta into what? E theta hat. C. So this is the cylindrical coordinate representation of relative acceleration between two moving points P1 and P2 in frame F. Alright, fine. Is it clear? So the two expressions we have for velocity and acceleration, we have already derived it. Fine. So this I rub it now. Alright. So what are the two results which we have obtained? First, we have obtained the expression for relative velocity between 2 points P1 and P2 in frame F in cylindrical coordinate representation for the case when 2 points are confined to move in same plane. So that is how much? dr by dt into er plus r omega e theta hat, and a P2 P1F, relative acceleration between P2 and P1 in frame F for the case when the 2 points are confined to move in same plane. This is just equal to d2r by dt2 minus omega square r into er hat 2 omega dr by dt plus r beta into e theta hat. C. Okay, fine. I rub this one. Now see, let us this denote this quantity by V relative, say. And let A P2 P1F be equal to A relative, say. Alright. Fine. Now wait. Now observe one more thing. I draw the diagram again. See, this is the frame F. This is the line P1, P2. Suppose this is the velocity V1F. It makes angle theta 1 with this line. Velocity of P2 is V2F with respect to F at time t. It makes angle theta 2 with the line P1, P2. This is the unit vector ER hat. This is the unit vector E theta hat, as I have stated just now. Now you know this Vp2 P1F is what? That is V2F minus what? V1F. Alright. Now V2F, what I write is V2F. V2F cos theta 2 ER hat. V2F sin theta 2 E theta hat minus V1F cos theta 1 ER hat. V1F sin theta 1 E theta hat. This becomes V2F cos theta 2 minus V1F cos theta 1 into ER hat plus V2F sin theta 2 minus V1F sin theta 1 into what? E theta hat. Is it alright? So this term is equal to this and this term is equal to this one. This and this are identical, you can say. They are the same equation. This is Vp2 P1F and this is Vp2 P1F. They are both same. You can see. So I rub this, okay, fine. So what I do, this expression and this expression, they are identical. I equate the corresponding coefficients of ER and E theta on both sides. This equation, this one and this one, they are the same equation. In these two equations, we equate the corresponding coefficients of ER on both sides. So what do we get? If we equate the coefficients of ER on both sides, what do we get? V2F cos theta 2 minus V1F cos theta 1. Okay, that is same as dr by dt. Okay, and if we equate the corresponding coefficients of E theta on both sides, then what do we get? V2F sin theta 2 minus V1F sin theta 1 is same as R omega. Okay, so omega becomes V2F sin theta 2 minus V1F sin theta 1 by R. Okay, now this you will recognize this is what? This is just this quantity is the relative normal speed between the points P1 and P2, and R is the separation between these 2 points. So you must recall that this we have already discussed in the second chapter on rigid body kinematics, second video on rigid body kinematics. I did not prove it there, but the proof of this has been given here. Okay, so this formula can be applied even when separation between the 2 moving points is not constant. And this case, you know, this also I've already discussed in the second video on rigid body kinematics. Okay, fine. This I'll grab it now. Okay. So now we take 2 cases, case 1 and case 2. Case 1, R is constant. And the points P1 and P2 move in such a way that the separation between these 2 points is constant. This will imply from the rule of calculus that dr by dt is 0. So this term goes away here. So this means this equation, this minus this equal to 0. V2F cos theta 2 minus V1F cos theta 1 becomes 0. This is V2F cos theta 2 is equal to V1F cos theta 1. This is just a familiar condition. It is called the rigidity constant, as was discussed in the second or third video of the relative velocity chapter. whose playlist has been given in the channel. Okay, if you go open that playlist, you'll get it there. So V2F cos theta 2 is equal to V1F cos theta 1, just the rigidity constant. What does this say? If distance between two moving points P1 and P2 is constant, then at any instant of time, component of velocities of P1 and P2 along line joining them are always equal in magnitude and direction both. And omega of that line will be given by this formula, relative normal speed by separation. This quantity is just the relative normal speed between P2 and P1, and R is the separation between these 2 points. Alright. So this also I'll rub it now. Now I take up case 2. Case 2 I assume that R is not constant, R is variable. That is, R separation between the two moving points changes with time. In this case, if R is not constant, then dr by dt is also non-zero. So in this case, if we see these two equations, this term becomes non-zero. So this means V2F cos theta 2 minus V1F cos theta 1 is non-zero. But this equation is still valid instantaneously. This also I have discussed in those introductory videos of rigid body kinematics, whose playlist is again given. Playlist. Okay. Omega becomes how much? This formula again becomes here also. Variable here also it is valid. This also I have discussed fully. I hope you remember it. By R. So here again this is the relative normal speed by separation. And R is the instantaneous separation between P1 and P2. That is separation between the points P1 and P2 at time t. So omega of that line at time t is given by this formula. So this already I have discussed in the introductory videos on rigid body kinematics. If you search the closed playlist, you'll get all those things. You'll get it. Okay, fine. So omega is equal to V2 of sin theta 2 minus V1. So relative normal speed by separation. R is the instantaneous separation. All right, fine. Now, I just consider one more point. This is the frame F, this is the line P1, P2, okay? Suppose acceleration of P1 is A1F with respect to F at time t. This makes an angle of say phi 1. P2, acceleration of P2 with respect to F is A2F at time t. It makes an angle of phi 2 with the line P1, P2. Okay, fine. And ER is theta as usual. Okay. See, I have found the relative acceleration between these 2 points, AP to P1F. This was A2F minus A1F. And this we have derived already. It is how much? d2r by dt2 minus omega square r into ER hat plus 2 dr by dt into omega plus r beta into E theta hat. Okay. Now what I do? I again express A2F, A1F in terms of these vectors. E1 hat, ER hat, E theta hat, phi 1 and phi 2. So what to write A2F? A2F will be equal to A2F cos phi 2 ER hat plus A2F sin phi 2 into E theta hat minus A1F cos phi 1 ER hat plus A1F sin phi 1 into sin phi 2 into E theta hat, and that is equal to this term. Now this ER E theta I collect common. So what do we get? A2f cos phi 2 minus A1f cos phi 1 er hat plus A2f sin phi 2 minus A1f sin phi 1 into E theta hat is equal to this term. So if we equate the corresponding coefficients of ER and E theta hat on both sides, what do we get? We get A2f cos phi 2 minus A1f cos phi 1 is equal to d2r by dt2 minus omega square r. And if we equate the corresponding coefficients of E theta in both these equations, then what do we get? A2f sin phi 2 minus A1f sin phi 1 is equal to 2 dr by dt into omega plus r beta. These are the two equations which we have obtained, okay? Now, implication of these two equations will be discussed in the next video, in the 33rd video on rigid body kinematics, okay? In 33rd video, the third chapter on rigid body kinematics will be finished. And in 34th to 3 to 4 videos, I'll take up the last chapter on rigid body kinematics. That is the concept of instantaneous center of rotation that we have discussed. It's a very important concept in mechanics, especially in rigid body dynamics and kinematics, okay? So that we'll discuss in the coming videos. Then this will be finished, and then I'll take up the laws of motion chapter. All right. So you go through all of them properly, okay? So if you understand it, it's very good. You don't have to go anywhere else, and you just understand, go through it, understand it fully. If you have any doubt, write it in the comment box. I'll discuss it, and then you solve problems from whichever source you have. You solve them, okay? And I am sure you'll be able to solve most of them. In case you have a problem, you can write to me in the comment box. I'll discuss it. Fine. And all the videos, the playlists have been made. If you go to search them in the playlist, all the playlists you'll get it there, okay? So I close it here. Fine. All right.